SAT is notorious for giving you concepts that you know in a format that you don't know. Well, in this video, you will see how to solve some SAT questions without overthinking them. An analysis of ticket sales for an no, we're not going to read it. It's too long. It's all we care about is the basics, okay? We care about the numbers and the question, the actual question, not the whole thing. We don't care about if it's opera or if it's performance or what. We're going to first look at this number right here. 6 times as many people attended the performance at night as attended during the day. Done. First equation, done, right there. Next, go straight for the second number. 2,500 more people attended the performance at night than the day. That's easy as that. No need to look further. Second equation, boom, done. Go straight for the question. Look for words such as how, who, when, where, and what. And so the word how indicates there's a question. How many people attended the performance of the opera during the day if each person only attended one performance? Okay, that indicates we're looking for daytime. We're looking for the daytime amount of people. And having already set up our two equations, we know that n is already by itself. That makes it convenient to set them both equal to each other so we can solve for d, which is daytime. We move the d's to one side. 5d equals 2,500. Divide everything by 5. You don't even need a calculator. You can do it in your head. d is 500. Done. Don't overthink this. Next question. A line is graphed in the xy plane that contains the points c negative 14 and c plus 9 negative 41, where c is a constant. If the y-intercept of the line is c plus 2 comma k, what is the value of the constant k? So we have two constants here. We are looking for k, but we also need to find c beforehand. We know that c plus 2 comma k is our y-intercept. So we set c plus 2 equal to 0 because the y-intercept's x-coordinate is 0. So c equals negative 2. We take the other 2 points, we plug in c. We get negative 2, negative 14, and 7, negative 41. Now we need to find the slope. And we can label these points accordingly. x1, y1, x2, y2. And our slope formula is m equals y2 minus y1 over x2 minus x1. We use this slope formula. We use the slope formula to solve using our points that we have. And so we plug all the values in, and we get negative 3 as our slope. Finally, here's a way to find the constant k without even using the slope formula a second time. So what we can do, we can take one of the other points that we found, but I prefer the negative 2, negative 14 just because it's easier. We label this point as a and our destination point, which the one that contains the value that we want to find, as b. So if a is negative 2, negative 14 and b is 0 comma k or ok, we can actually find the change in x from this point to that point. If slope is negative 3, the change in x is 2. We must multiply negative 3 by 2 and then add it to the original y value. So that means if the x's go up by 2, that means your y's must go down by 3 twice. So negative 3 times 2 is negative 6, and negative 6 plus negative 14 is negative 20, and our constant k is negative 20.